Hello students, today I'll be discussing on the chemical reactions of amines. Now, the chemical reactions in amines is because of the difference in the electronegativity between nitrogen and the hydrogen atoms, and also the presence of unshared pair of electrons over the nitrogen atom, making amines reactive. Now, the most important point here is the number of hydrogen atoms attached to nitrogen atom also decides the course of the reaction of amines. Same reagent in all the three amines. The same reagent may be used, but there are different rate of reaction because of the acidic presence of acidic hydrogen. Now, as we see here, in primary amines there is presence of two acidic hydrogen. In secondary there is only one hydrogen, and in tertiary amines there is no acidic hydrogen. Therefore, all the three amines undergo different rates of reaction. Now, therefore, we can summarize that the reactivity is due to the acidic hydrogen and the lone pair on nitrogen atom. Also, another reason for the reactivity is that the electronegativity difference between nitrogen and hydrogen. Since nitrogen atom is more electronegative than the hydrogen atom, a polar bond is created and nitrogen becomes partially negative and hydrogen becomes partially positive. Therefore, from this we say that amines are reactive because of the presence of the acidic hydrogen and the lone pair on nitrogen atom. Now let us discuss the basic character of amines. Basic character of amines. Now, why amines have this basic character? The main reason is it is due to the lone pair on nitrogen atom, due to the presence of the lone pair on nitrogen atom. We know that amines, they are basic in nature, therefore they react with amines being basic in nature, they react with mineral acids. Mineral acids can be of any, the halogen may be X, maybe Cl, Br, or iodine to give a salt. Amines react with the mineral acid to give a salt of the type NH3X-, and this is a salt. Now this amine salt on treatment with a base, when it is treated with a base, it regenerates into the parent amine where there is removal of NaX- water molecule. Now this shows that amines are basic in nature. Now even in aniline, in aryl amines aniline, the lone pair on nitrogen atom takes the hydrogen atom, and then the bonding electron pair goes to the chlorine atom, and then we know that the halogens are good leaving groups. Therefore, along with the bonding electrons, the chlorine, the halogens leaves, and then it forms the salt of the type. This salt is known as anilinium chloride. Now, from here we see that amines are basic in nature. This reaction shows how easily the nitrogen atom takes away the hydrogen atom from the mineral acid towards itself to form the salt. All the three amines, that is the primary, secondary, and the tertiary amines, will undergo this reaction because all the three amines have lone pairs on the nitrogen atom, but their basic strength will differ. Now, how will their basic strength differ? Let us check. Now let us see the order of basicity. The order of basicity. Now, experimentally, it has been found that amines they act as a Lewis base. Amines they act as a Lewis base. And we know that what Lewis base, the definition of Lewis base are. Lewis base are good electron donors. Now, these amines react with as water reversibly to form a cation. Now from here, taking the equilibrium constant, Kp values, the equilibrium constant can be written as here again. This equation can be rewritten as the concentration for water molecule is neglected. Okay, from the equilibrium constant we know that the pKp value is equal to minus log of Kp. Now we take this as because this gives this value, the pKp value gives a reasonable value for the equilibrium constant of amines. Now if the concentration of OH minus increases, the concentration of OH minus increases, then the Kp value will also increase, but the pK value will decrease. If the concentration of OH increases, then Kp will also increase, but pKp value will increase. Now this will result in the basicity will increase. Therefore, now taking this equation into consideration, let us compare the basicity of ammonia versus alkyl amines. In this comparison, let us take that alkyl amines. In this comparison, for alkyl amines means it will be common for all the three amines, that is the primary, secondary, and the tertiary amines. Now let us find which of the two will be more basic. Now experimentally it is found that the pKp value of ammonia is 44.75 and that of amines is 3.75 to 4.22. Please remember that these values are for your understanding and do not memorize these numbers. It is just for understanding. Now we have further, if the pK value decreases, then the basicity will increase. Now comparing ammonia and alkyl amines have less pKp value than that of ammonia. Therefore, less pKp value means the basicity will be more. Therefore, alkyl amines we have here, and then ammonia. Since ammonia has more pKb values, therefore it will be less basic than that of alkyl amines. Now this can be explained on the basis of the lone pair donation. Now we know that a base easily donate its lone pair. Now keeping this in mind, we see here, now in ammonia molecule, here is our ammonia molecule, and this is our alkyl halides. Now in alkyl halides there is an R group, whereas in ammonia there is no R group here. This R group has plus I effect. Now since this is an electron releasing group, the plus I effect pushes the electrons away from here, and then makes the electrons as this pushes the electron away from it, the electron density on nitrogen atom increases, and thus it makes the availability of the lone pairs very easy. Therefore, we can conclude that the presence of the R group having plus I inductive, plus I effect is also one of the reasons for the increase in the basicity of the alkyl amines, because the electron density on the nitrogen atom increases, which makes the availability of the lone pairs more easily available for donation. Therefore, it can be concluded that the lone pairs are easily donated, and thus ammonia is less basic than that of alkyl amines. Now for the comparison of primary, secondary, and tertiary amines, and also for the and also the comparison and with some conditions we will be discussing in the next video.